Hello friends, I welcome you all to this class. This is mathematics class, and today we have this interesting example to solve on this topic we looked at in our previous class, differentiation from the first principle. And I told you that in our previous class that I will be showing how to find the derivative of a function from the first principle using some examples. So today actually this is making it the third example we are considering on this topic. So what is given to us, they told us to find the derivative of this function y is equals to x plus 1 over x. Your x should not be 0, because if x becomes 0, if you do 1 over 0 is actually infinity, which is undefined. So that's why they put this condition that x is not 0, just to make sure that this function is defined. They asked us to find the derivative of this from the first principle. So we start the class. We first of all write our function. So we say that f of x, the function given to us, f of x, this is the function of x. Actually, this is a function of x. So we write the function to be x plus what? 1 over x. So this condition does not, we are not going to use the condition to solve any problem. The condition given in the question is just for the function to be defined. That's the essence of the condition. So we are going to write the definition of the derivative of the first derivative of a function from the first principle. So we denote that derivative as f prime of x. This is f prime of x. So this will be limit as h goes towards 0 of f of x plus h minus f of x divided by h. This is the definition of the derivative of a function from the first principle. And this is the first formula that is expected to be seen in your answer booklet if you are solving if you are giving an example to find the derivative of a function from the first principle. After writing your function, you write this formula, then you follow the formula to finding the derivative. So we have limit as h goes towards 0 of f of x plus h. So what is inside the function now is what? From the formula we have, what is inside this function here is x plus what? H. So we are going to, in this function, we are going to replace anywhere you see x, you replace it with what you have inside the function. So instead of this x here, what I have inside the function is what? X plus h. So this x plus h is in place of this x, because this is what I have inside this function. The next one I have is what? Plus. The next thing I have is 1 over x. But what is inside? What is our x now? What is inside the function is what? What's inside the function is x plus h. So I will remove this x and put what's inside the function, x plus h. So I'll put x plus h. So in other words, we are replacing x in this function with what is inside the function. What is inside f? X plus h. So I'll replace this by x plus h, replace this by x plus h. The next thing I have is what? Minus f of x. Minus f of x. F of x is the original function given to you in your question. That is x plus 1 over x. This is the original function, and that's your f of x. Then we'll have this all divided by what? H, according to the formula for the derivative of a function from the first principle. So this is limit as h goes towards 0 of, we can simplify this expression. So let's just, we'll have what we have here is x plus h plus 1 over x plus h. Then we can open this bracket by minus. Minus multiply positive x is minus x. Minus multiply positive 1 over x is minus 1 over x. All divided by h. If something can cancel here, x can cancel minus x. So what is now remaining is limit as h goes to 0 of h plus 1 over x plus h minus 1 over x, all divided by h. This is what I have left. So what I have, this is a fraction, right? This is a whole number. I can make the denominator of h to be what? 1, so that I can solve the fraction up here, up there. So I'll now have limit as h goes towards 0 of, so I'll now find the LCM of this fraction. LCM of 1 and x plus h and x. So of course the LCM is x times what? This quantity. So the LCM is x times this, x plus h. So I will now write x times x plus h. That's this denominator times this denominator will give us the LCM. Then you now do over, then you start solving the fraction. So what is down here is 1. 1 divide this quantity will give us this quantity times h. So I'll have h times this, so that's h times x open bracket x plus h. Then next you come to this second fraction. What is down is what? X plus h. We divide this. X plus h divide this. This will cancel this, remaining x times 1. You have what? Plus x. Because x times 1 give you x. Then what is here is what? What is down here is what? X. X will divide this quantity. X and x will get cancelled. Remaining this. Remaining x plus h. X plus h will multiply this 1 up there. So remember I have minus before. So x plus h multiply this 1 up there, we have x plus h. I'm putting it in this in bracket because I have minus before here. Then we have this all divided. Remember I have all divided by h. So this will be limit as h goes towards 0 of this thing. Now I can open this bracket. So hx times x, I have hx squared. Then plus hx times h, I have h squared x. Then I have plus x here. Then if I open this bracket with minus, minus times positive x is minus x, and minus times positive h is minus h. All divided by what? What do you have? X open bracket x plus h. All divided by what? H. We are following the formula. So this will be equal to what? Limit as h goes to 0. So we can check some things can cancel. X can cancel minus x. So what is now remaining up is hx squared plus h squared x and minus h, all divided by x open bracket x plus h, all divided by h. So this will be limit as h goes to 0 of. So we try to simplify this expression. We try to simplify it. So what clearly h is common here. H can come out of this expression. So h is common. So I can factor out h. So I have h. If I factor out h, I will divide everything by h up here. So here will be remaining x squared. Then h divide hx squared will be remaining positive hx. And h divide minus h will have minus 1. So all divided by x into x plus h. All divided by what? H. So this is what we have. So this will be equal to limit as h goes towards 0 of. So this quantity down here, this h here can cancel this h down here. So if they cancel, you now have x squared plus hx, okay, minus 1, all divided by x into x plus h. So we can evaluate the limit now. H is going to 0. H is going to 0. You can put 0 for h here. So, and anywhere you see h, you substitute h for what? 0. So you have x squared plus, instead of hx, it will be 0 times x. Then minus 1, all divided by x, open bracket, x plus what? 0. So this will be equal to x squared, because what is remaining here will be x squared, and 0 times x is 0. Then minus 1 divided by x plus 0 is what? X plus 0 is x. Then x multiply x, I have x squared. So this will be x squared. X squared plus 0 is x squared minus 1 divided by x squared divided by x squared. So this is what we have. For simplification, for us to simplify it further, just for simplification's sake, I can divide each of them by this denominator. So the first thing is x squared. I have x squared divided by the denominator x squared. Then minus this one divided by the denominator 1 divided by x squared. So x squared divided x squared will give you 1. Then minus 1 over x squared. So this gives us the derivative of this function from the first principle. So I'm expecting you in our upcoming class. So thank you so much for being part of this class. See you in our upcoming class. Bye.